Welcome. In this session on natural deduction, we'll explore two rules for implication elimination. Implication is when one thing implies another. In English, it's usually an if-then statement, and elimination is how we can use rules in natural deduction to reduce an implication to a simpler formula. By implication, strictly we mean material implication. That is, that there is a truth relationship between the two parts. When we have a formula, for example, phi, and phi material implies psi, what we're saying is that this is the antecedent and this is the consequent. Some authors will use different terms. I'll try to use antecedent and consequent. And if we see a formula that has this structure, and we also see the antecedent on its own line, from that we can conclude the consequent on its own line. And that is written as implication elimination. Another term for this is also called Modus Tollens, which is Latin for method of affirming. A related rule is Modus Tollens. And in Modus Tollens, if we see a formula, phi, that implies a formula psi, and if we see the negation of the consequent on its own line, we can conclude the negation of the antecedent. This is called Modus Tollens, which is a method of denying, and strictly speaking in natural deduction, we can get by without this. In later sessions, when we explore methods that involve contradiction and methods involving assumptions, we'll see that we could get by without this. However, it's a very useful rule at this point in our understanding, so we'll include this. And in our form of natural deduction, whenever we have symbols, that usually means that this is a basic rule of deduction. And when we have letters, that usually means that we have a derived rule. Let's try using modus ponens in a proof. Suppose we are given the premises of P and that P implies Q and the double negation of R, and from that we want to conclude that R is true. We always begin our proofs by writing down the premises. Now we have two premises, so this would be one is P, that's a premise, and two, we have P implies Q and the double negation of R, so that's a premise. I always write the conclusion so that I can employ forward reasoning and backward reasoning as I need. And here, my conclusion is simply R. If I use forward reasoning, I see P, and I see that P is the antecedent of an implication, and that means I could apply implication elimination. I'll do that. So line 3 of my proof will be Q and the double negation of R, and that will come from line 1, line 2, and implication elimination or modus ponens. If I now look at this statement and I look at my conclusion, I see that I could get my conclusion if I could pull this around and then remove that double negation. So using this combination of forward and backward reasoning, I'll say that I want line 4 to be the double negation of R, and I can arrive at that by using line 3 and conjunction elimination type 2. Now I see that this line follows directly from this line, so my proof would be complete if I deduced R by coming from line 4 and double negation elimination. So now I've used modus ponens in a proof. Next, I'll try a different one. Suppose that we are given as premises that not P implies not Q, and that Q is true, and we want to conclude that P is true. We begin, as always, by writing down what our premises are. So here, premise 1 is not P implies not Q. So that is a premise. And the second premise is Q. My conclusion is P. And if I look at these, I don't see any immediate path that I can apply these to. So let me look at the rule of Modus Tollens carefully. It says that if I see a formula implying another formula, and if I see the single negation of the consequent on its own line, that I can conclude the negation of the premise. So here I have an implication, and the negation of Q is the consequent, and Q is on a line of its own. Well, I can't directly apply this, although logically we would think, oh, Modus Tollens certainly applies. Strictly speaking, if we look over there, it doesn't. So what I would, in order to get there, I have to have the negation of the consequent on its own line. That is, I have to have the double negation of Q on its own line. Well, I can arrive at that from line 2 if I use double negation introduction. Now I can apply Modus Tollens, because now I have the negation of the consequent and an implication, so I can infer the negation of the premise, of the antecedent. So I can infer the negation of the antecedent, which is the negation of P. And I can do that by applying line 3 and line 1 and the rule of Modus Tollens. Well, now I can go directly to my conclusion. So line 5 of my proof, P, we can arrive there if we use line 4 and double negation elimination. So in this session, we've looked at what material implication is, we looked at 2 rules for eliminating it, and we've applied these 2 rules in 2 simple proofs.